P5 algebraic expressions. So we have some vocabulary we should talk about first. A variable. A variable is a symbol that can represent any number from a given set of numbers. X, Y, Z are pretty typical variables that we use. Algebraic expressions are combining variables and numbers using addition, subtraction, multiplication, and division, powers, and roots. So we see some examples here like 2x squared minus 3x plus 4. Monomial is an expression of the form a times x to the k, where a is a real number and k is a non-negative integer. So it's just one term. A binomial is the sum of two monomials, so there's two terms. Trinomial for three terms, and in general we call the rest of them polynomials, the sum of any number of monomials. At some point we just kind of stop coming up with names, so poly means many. A polynomial in the variable x is an expression of the form a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, and so on, until we get a sub 1 x to the first times a sub 0, where a sub 0, a sub 1, and a sub n are all real numbers, and n is a non-negative integer. If a sub n is not equal to 0, then we say that the polynomial has a degree of n. So for example, in Algebra 1, you would have talked about, say, a degree 2 would be a quadratic, or a degree 3 would be a cubic. So that tells us down the road how we can graph these things. The monomial a sub k, x to the k, that make up the polynomial are called terms of that polynomial. And note the degree of the polynomial is going to be the highest degree out of all of the monomials. So for example, if I have 3x to the 6th plus 4x to the 3rd minus 2, the degree here is going to be 6. And that helps us to figure out what our graphs are going to look like. So the first thing we want to do here is just complete this table, and we want to figure out what belongs where. So what type is it? Is it a monomial, binomial, trinomial, or a polynomial? So if I take a look at the first one, we see 1, 2, 3. So that is a trinomial because there are 3 terms. In the next column, what I want to do is figure out the degree. So out of all the terms, I have 2x squared, negative 3x, and 4. So the degree is the highest exponent. I'm seeing a 2 here. So this is second degree, or we would call this, I can't fit that all in. We call it second degree, or we would say it is quadratic, like a parabola. The next one has 2 terms, 1, 2, so that's a binomial. Out of my binomial, I see that 8 is the highest exponent, so we do not have anything special here. We would just say that this is degree 8. I see 1, 2, 3, 4, so this is a polynomial. And the highest exponent I see is a 3, so this is a cubic, if you remember from Algebra 1. 2 terms, so 2 terms here, we have a binomial. The highest exponent is technically a 1, so that is linear or a line. 1 term, so it's a monomial. The highest exponent is a 5, so for 5 we say that is quartic. Which sounds like it should be 4, but 4 is quintic. Or do I have that backwards? Sorry, quintic. I'm sorry. Summer brain. Quintic, like quintuplets. Quintic. Okay. And then 6, we have 1 term, so that is a monomial. Quart, like there's 4 quarts to a gallon. Quintic, like quintuplets. And then 6 is just a regular number with no variable, so we call that a constant. Or if you needed to say the degree here would be 0. All right, addition and subtracting, or adding and subtracting of polynomials. So when adding and subtracting polynomials, we use the idea of combining like terms using the distributive property. So we just want to use the terms that are the same and deal with their coefficients. So when we're adding, we're going to find all of them. That's x to the 3rd. So there's 2 of them. That's 2x to the 3rd power. And then we have a negative 6x squared and a positive 5x squared. So that's a negative 1x squared. And we have a 2x and a negative 7x, so it's a minus 5x, and then the plus 4, which is by itself. The only thing different is when I am subtracting, what I want to keep in mind is this negative symbol has to be distributed. So we tend to like to rewrite first. X cubed minus 6x squared plus 2x plus 4. All of those change signs. That's a minus x cubed, a minus 5x squared, and a plus 7x. All of them change sign. And now again, I'm just going to combine my like terms. I have an x cubed and a negative x cubed, so they actually cancel. I have a negative 6x squared and a negative 5x squared, so that's a negative 11x squared. I have a 2x and a 7x, so that's a 9x. And again, I've got that lonely 4. I like to do colors. If I only have a regular pencil, sometimes I'll underline, or maybe I'll do like a square around the cubes and a triangle around the second power. Whatever works for you, it doesn't really matter. Multiplying algebraic expressions, aka FOIL. Now, I don't love the term FOIL, but it's a silly way to remember first, outside, inside, last. I like to think of it as repeating the distributive property over and over again. That way it does not confuse things when you get to more than a binomial times a binomial. But what we're going to do is take this 2x and we are going to distribute it to both terms in the other parenthesis. So 2x times 3x is 6x squared. 2x times minus 5 is minus 10x. Then we are going to take the next term and distribute that. So 1 times 3x is 3x, and 1 times minus 5 is minus 5. And now we just combine like terms. So we get 6x squared. These guys go together, so that's a minus 7x minus 5. And that way it can apply to larger polynomials as well. So 2x times x squared is 2x cubed. 2x times minus 5x is minus 10x squared. 2x times 4 is 8x. And then the 3 also distributes. So that's a 3 times x squared, a 3 times minus 5x, so minus 15x, and a 3 times 4, which is 12. Again, lastly, we just have to combine our like terms. So this is the only cube. And I'll show you what I mean by maybe changing it up here if you only used one color. So maybe 2 lines and 2 lines, if that works. So negative 10x squared and positive 3x squared, so I put a double underline so I know they go together. And then maybe I'll do like a squiggle for the x's, so that's a minus 7x, and then the 12 is all by itself, so a plus 12. Special product formulas. So except for the last two, they should all look familiar. When I multiply, it looks exactly the same, just the sign is different in the middle. That gives us a difference of squares. So when we have a plus b squared or a minus b squared, those both give us a very special formula where the outsides are both of those integers squared, but the inside is double the product of the two of them. And then this sign depends on this one. Okay. The last ones are called sum of cubes a cube of a sum and a cube of a difference. And these can be very useful in terms of trying to figure out the trying to work backwards, right, when we're going to factor down the road. But we could also just work these out by hand. Just keep in mind, if you are multiplying them out by hand, that you've got a lot of FOIL going on here. So that a plus b to the third power does not mean a cubed plus b cubed. That is not correct. That would mean you have to write the parenthesis out 3 times and perform FOIL a couple of times here. Okay, so just keep that in mind. Though these are useful, and if you can memorize them, great. But it's not 100% necessary to memorize these. When we do get to factoring, there's some better ones to know. And then let's use those special products. So we can use them to find the product of each of these here, just to practice doing that. So if we're going to use the special product formula here, this is that a plus b squared. So a plus b squared would give us, let's write it here. A plus b squared gave us a squared plus 2ab plus b squared. And you might remember that from Algebra 1. So this is going to act as our a, and this is going to act as our b. So that makes 3x squared plus 2 times my a is 3x times my b, which is 5, plus b squared, which is 5 squared. That gives us 9x squared. That is 6, so 10x, and 25, as long as I didn't mess up my arithmetic there. Oops, ooh, what happened? Lost a lot of stuff. Where are we at? Sorry. All I have to do is ever so slightly touch the number on the outside. Whoops, I totally messed up my math too. I added. I don't know what I was thinking. Sorry about that. That is not a 10. 2 times 3 is 6, times 5 is 60. Sorry. Nope, 30. Oh my goodness. Summer brain. Okay. So x squared minus 2 cubed. So the formula for cubing, a, we have minus b cubed. That was a cubed minus 3a squared b plus 3ab squared minus b cubed. Okay. So again, this is acting like my a, this is acting like my b, and the symbols are already figured out for me. So I'm going to do my a cubed, so that's x squared cubed, minus 3 times a cubed, no, sorry, a squared, times b, plus 3 times a times b squared, minus b cubed. Okay, so that is the 2 and 3 we multiply. That's x to the 6th power. Let's see, we'll have a negative. That becomes an x to the 4th. 3 times 2 is 6. That's 2 to the 2nd is 4, so that's a 12x squared, and 2, 4, 8. So minus 8. Again, as long as my arithmetic is correct, which I believe this time we're good. Okay. The next one is going to produce a difference of squares. I see it's the same thing written twice, just one is a minus sign, one is a plus sign. So we are going to multiply these two together, and that will give me 4x squared. And we'll multiply these guys together. Root y times root y is just y. And then we put a minus sign in between the two. Okay. Oops, forgot to box that in. All right, and then lastly, there's a few ways we can do this. We certainly could sit here and FOIL the whole thing out, but what's kind of neat about this is it's actually a difference of square. Oh, sorry. It's actually a difference of squares all over again. Here we go. It's a difference of squares all over again if I think of it this way. This part can be my A, and this part can be my A. This is my B, and this is my B. And if I do it that way, I can actually make my life a little bit easier. So remember, with difference of squares, that's a squared minus b squared. So a squared minus b squared. But this is a special formula. We know that from just up top. So that's a squared plus 2 times a times b plus b squared. And then we still have that minus 1 squared, or minus 1. There is nothing wrong with sitting here and FOILing multiple times. It will get you the exact same answer. These are just